Hi, well, this is Brendan, and this is 30 Days of Solidity, where I'll be doing day 7 for simple IOU. Now, as with the previous days, I've already created a empty Solidity file and copied over the description from the challenge calendar page. Something I've done additionally is I've gone to the deploy page and look through all of the accounts, right, and copy them one by one so that it's more convenient post-deployment. Let's begin. So for the simple IOU, I am actually going to copy a lot of the code over from piggy bank, right? I don't think that we need to sort of we don't need to repeat that code. I'm just going to copy paste this in my own code. I'm going to remove balances because we will not be using that. But essentially, I'll have a constructor which sets who the manager is, right? And the manager with a role is only allowed to perform certain actions according to the only manager thing. And then there's also a only member modifier as well, which we haven't used yet. The add member and remove member functions are as they were before, right? Basically, only the manager can modify this members list. All right, now we're ready to write the parts that are different from the parts that are different. So firstly, we need a function for new IOU, and we'll make that public payable, and just close that for now. We'll add to it, and then so there's new IOU, and there will also be settle IOU, right? So, and let's type what that actually includes, right? So creditor sends money to debtor. Logging an increment in IOUs mapping, right? And this one will be the other way around. The debtor sends money to the creditor, and it logs a decrement in the IOUs mapping. And we'll get to the IOUs mapping in a bit, right? All right, so what essentially needs to happen is IOUs, which is a mapping, but it'll be a mapping within a mapping. IOUs, debtor will be the first key, and then creditor plus equals message.value. So because this function is payable, you can transfer in cryptocurrency with the transaction, and it logs that value there. And the second important thing that needs to happen is that the debtor needs to transfer this smart contract will transfer to the debtor, right? Transfer message.value, right? Right, so what are debtor and creditor, right? So in this case, message.sender will be the creditor. Address creditor is equal to message.sender, and debtor will be specified as a parameter, address debtor. All right, now this isn't going to work because this is an address and it's not a payable address, and that is easily fixed. And the final thing is we need an IOUs mapping, right? So previously we had, when we copied it from piggy banks, we had a balances one. So now we'll have a mapping of address to something, call that public, and then IOUs, right? Now what is this something, right? That's going to be another mapping of address to UA 256. So that allows us, okay, yeah, maybe it doesn't allow a parenthesis in here, all right. So this is a mapping within the mapping, right? So the first key will be for debtor, and then the second key will be for creditor. So we'll use it like this. So I'll just give you a sample. IOUs debtor, creditor, equals to amount. Right. The UN 256 is the amount. All right, and that's exactly what we've done here. Right. So essentially, right, we have IOUs debtor creditor, and we increment the value that's stored inside the mapping. So the value of the IOU has been incremented by the value of that was sent into this function, and then we transfer that value out from the smart contract immediately within the same transaction to the debtor. So the debtor receives the payment from the creditor, but first it goes through this smart contract. The next thing that happens is when you want to settle an IOU, you have address, payable, creditor, and the same thing happens in reverse, right? So address debtor equals to message.sender, and then you can do this exact same thing. IOUs debtor creditor this time will be minus equal, so you decrement the value. Debtor dot transfer message dot value. Except that it's not supposed to be debtor dot transfer, it's meant to be creditor dot transfer. So now the debtor is paying the creditor back what they're owed, and then we are logging that this change has happened. All right. So far, we've got the basics down, right? Now, I'm going to modify the only member modifier over here to not use message.sender because we need to perform it on both the debtor and creditor, right? So I'm going to say address A, address B. Actually, let's make it simpler. Just address A. Members bracket A. Only a member is allowed to perform this action. Perform or be party to. Right, so it's not always about message or sender anymore. So only member, and so what I'll do here is only member for message.sender, and also only member for debtor. Right? I'll do the same thing here. Only member message.sender and creditor. That way we know that both the debtor and the creditor are members before proceeding with the rest of the logic. And another thing we'd want to do is to ensure that the payable amount is non-zero, because otherwise it'd be a redundant transaction. So add another modifier, non-zero payable, non-zero amount. Let's just put it that way. Set amount underscore and require that message.value is more than 0 . Say non-zero amount required. So we'll make that a non-zero amount as well. All right. And maybe one more thing that I'll do is another function. I will get a way to easily extract these values. But I also want to make use of these only member functions as well. So it's not as simple as just querying a mapping and getting 0 values, right? You want additional information, and only for it to be queryable if members are really members, right? So I'll do public view and then return this uint 256 amount, right? And then I'll have address debtor, but it doesn't need to be payable in this case, and address creditor. And then I'll do amount equals to IOU's debtor creditor. So this is just retrieving the value. But you could accomplish this just by the auto-generated public function for this mapping of the mapping. But what I will do here is to add additional value by saying this only member debtor and creditor. So both the debtor and the creditor, so this will essentially have additional required statements for debtor and creditor. All right, this is actually it. The implementation should be complete, but I think what I might do is I'd also keep track of what is the total amount that's owed across all of the debt, across all of the IOUs, and also what is the total that has been transacted to date, because that might be relevant information, right? So let's do, so total owed plus equals message.value and total transacted plus equals message.value. I'll do the same thing here. Alright, so total owed minus equaled, but total transacted will be also plus. So when someone creates a new IOU, the amount that is in that IOU increases both total owed and total transacted, and then when someone pays back that money, then the total owed decreases by that amount, but the total transaction increases by that amount, because we're tracking two different things. So yeah, that would just give some interesting stats. Yeah, let's actually this here. Uint 256 total owed, public total owed equal to 0, calculate, and total transacted is equal to 0 as well. Alright, I think that should do it. So checking that compiles. Okay, so now I'm going to deploy it. Alright, let's make sure I've got the first address selected as the account to deploy with, and now I've got a deployment. Alright, so now I've got a simple IOU, and what I'll do is I will add a couple of members and not add default address as a member. Okay, so add member and add member, right? So let's query the members. So if I paste this one, yep, it's that account is a member. Now if I paste this one, which I didn't add as a member, that will be false. All right, now let's switch accounts from this one to the second account, so 88, and type in quadruple one. And I'm going to create a new IOU and send that to this address, right? So new IOU, and so that means that this account has transferred quadruple 1111 to the smart contract, which in turn has transferred it to this address, right? This the third account, right? And that's basically what happened here, right? So the debtor has received the money. Now, if you take a look at the total owed, there's only one IOU so far, so that's quadruple one, and the total transacted is also quadruple one, as expected. Now, let's say we have we want to do a settlement, right? So we got 4B2, right, the third account, which is the debtor. The debtor wants to return the money, right? So I'll do settle IOU from this account now back to the original owner, right? But the amount that I'll send is not the full amount, right? It's just going to be 1,000. So there's going to be 111 left over, right? So let's do settle IOU. Now let's take a look at the total owed. Will be 111, and the total transacted will be 2,000 and 111, as expected. Now let's try and do an amount that doesn't exist, right? So let's say, remember that it was owed 111 left because we only paid 1,000 off, right? So let's try to settle IOU again, but this time try to settle with 200, which is more than the amount that's owed. Let's press settle IOU, and it says transaction has been reverted, and it says the value should be less than, it's not enough. So I'm the 4B2 account and I'm trying to settle it with AB8, right? Now let's try it with a value that does get allowed, 100, right? Now we'll press settle IOU, and that indeed did work, right? Because the amount was less than the amount that was allowed. Now let's look at total owed. There's only 11 left, and total transacted is 2211, as expected. All right, so that demonstrates the simple IOU contract. Thank you for listening.